going on, guys? Let's do this problem right here. The first question is asking, burning 0.5 moles of carbon to form carbon dioxide releases 197 kilojoules of heat. How much heat is released if 44 grams of carbon dioxide is produced in a similar reaction? Now, to figure this one out, we have to write the balanced equation. So the equation related to this is going to be carbon plus oxygen giving us carbon dioxide. Here carbon is going to be solid and oxygen is going to be gas, and carbon dioxide is going to be gas, right? Now here this is already balanced because we have two oxygen, one carbon, one carbon. Now let's see. So from this reaction they are saying how much heat is released if 44 gram carbon dioxide is produced. Here from this one we know that if 1 moles of carbon react, if 1 moles of carbon reactant and 1 moles of oxygen reactant was there will be 1 moles of production of carbon dioxide. Now from this information, let's see what is this mole amount. To find this mole amount, we have to divide this one by molar mass. For carbon dioxide, molar mass is 44.01, and if you divide this one by that, molar mass is equal to mass over we are trying to find mole. Mole is equal to mass over molar mass, right? That way we will have 44 gram over 44.01 grams per mole, and gram cancels and this mole will flip around and go to the top. From this one we already know this is going to produce 1 mole. So according to this question they are saying 1 mole is produced. So in this case we don't have to do anything else because this is already 1 mole, so we don't have to do anything. And they are saying if 0.5 carbon form this much amount of energy. So let's see, if 0.5 carbon reacts with this reaction, we are going to produce 0.5 carbon dioxide, right? Because if 1 mole produces 1 carbon dioxide, 0.5 is going to produce 0.5 carbon dioxide. So if 0.5 carbon dioxide releases this much energy, then 1 mole is going to release double of this amount, because 0.5 is this much, 1 mole is double of that mole, so this is going to be double of this value. Double of this value is 394, therefore answer is going to be 394, right? Now let's look at the second question. Which element if used as a dopant in silicon would yield a p-type semiconductor? So generally if p-type of semiconductor are created from two elements, those are gallium and aluminium. Here we only have gallium right here, so we know the answer is going to be gallium. Now let's look at the third question. Which pair should have the largest lattice energy? To find largest lattice energy, we use this equation, that is energy is directly proportional to Q1 Q2 over R. Now let's look at the questions. Let's look at the answers. First we have sodium. So here we have two factors that's going to affect this one. This lattice energy, that's distance and charge. Now if you look at this one, sodium, chlorine. If you look at this one in periodic table the size increase in this way and in this way and this way, right? So in these two ways the size will increase. Let's compare sodium and magnesium. We know that sodium after we have magnesium. So magnesium is going to be smaller than sodium, right? Sodium is going to be bigger. And if the size is bigger, then the distance will be higher, because if two molecules bigger size, the distance from the center is going to be high. So this is going to be distance higher. Whatever the molecules combined with is going to be distance higher. Also we have to look at the other molecule. Now chlorine is in third period, right? Third period, and oxygen is in second period. And we know that as it goes down, the size increases. So third period size is greater than second period. So oxygen is smaller than chlorine, right? And also Mg has 2 plus charge, oxygen has 2 minus charge, charge is greater. So the answer is going to be this one, because we have charge greater, molecules are small, so lattice energy is going to be greater for this one. And if you look at this one, two of them are smaller compared to Mg and oxygen. And this one, Mg is smaller, but chlorine is bigger. Also, chlorine's charge is smaller. And if you look at the sodium is bigger and oxygen is smaller, but since we have bigger molecule, the distance is going to be higher. So if the distance increase, this will decrease, right? So that's how we find out that's how we solve these kind of problems. I hope you guys find this video helpful. See you next time.